In this video, you're going to learn how to create a subclass using prototypal inheritance. So to talk about exactly what that is and why it's useful, let's go ahead and write out the prototype chain for person, something that we already explored before. We start off with our instance, so something like my person. That inherits stuff from person.prototype. That then links to object.prototype. And then that links to null, the end of the prototype chain. We've already seen all of this in action. Now, the nice thing about this is that the person gets behavior from the object. But let's think about the thing that we've created. We've created a person. Imagine that we're working with an application that needs to use person, but also has a different type of in-person, like an employee or a teacher or a student. These are obviously all people. They all have names, ages, and likes, but they probably also have some subtle changes to them. For example, with an employee, we might want to track how long they've been at a company or what their title is inside of that company. Currently, what we would need to do is create an entirely new class with all of the same code from person. Then we would need to actually instantiate that new class, creating instances of it. That would work. The problem is the duplicate code. Using subclassing, we can actually create a class that inherits behavior from person. And this is going to be pretty useful in some situations. So let's go ahead and do just that down below. We're going to create a subclass for person that is very similar to person, but it is going to be specific to a person who's an employee. So we are going to track their current job title. To kick things off, we're still going to use the class keyword, and we're still going to give our class some sort of unique name. I'm going to call this one employee. Awesome. And then we're going to set up our curly braces. So we have a standard class employee. Now at this point, we are not inheriting any behavior from person, but we can do that using what's known as extends. So after class and the class name, we can optionally extend from an existing one. Right here, extends, which is a reserved keyword. Then after extends, we provide the name of the class we want to extend from. In this case, that's going to be person up above. Now what we have is a class called employee, which is extending from person. Since employee doesn't define any unique or special behavior, an employee has the exact same behavior as a person. We can prove this by swapping out the actual class we use down below. For this one, Andrew Mead, I am going to go ahead and use new employee instead of new person. Down below, though, I will still keep new person in place so we can compare and contrast the two. Now, if I save person.js, we can actually run the file and see what we get. I'm going to clear the output, rerun the script using the up arrow key twice, and what do we get? I get Alexis is 27, she likes teaching, and she likes biking. So there we go. We have the exact same behavior we had before using this new class. That's not particularly interesting, but what we can do now is start overriding various methods or providing brand new methods that aren't available on person. Now, by default, if we define nothing inside of here, it falls back to the parent's version of it. So when we create a new employee, we are calling person constructor. When we call an employee's getBio method, it is just like calling the person's getBio method. So at this point, we want to start overriding things to make employee unique, and we're going to start with the constructor function because employees are also going to have a position as well as first name, last name, age, and likes. So right here, we're going to define our own constructor. So now when we create a new version of employee, it is not going to actually run the parent's constructor function. Now let's go ahead and set up the arguments that we want for an employee. We're still going to have first name. We'll still have last name and age. Right here though, I'm going to set up position after age. Then at the very end, I'll set up likes. We can put these arguments in whatever order we want. I'm switching things up a little bit and not putting position last so we can see what that might look like. So let's go ahead and actually save things and test it out. Now, employees still have set name and get bio. We're going to leave those calls in place, but for the moment, we're going to comment them out. And all I want to do is just console.log me. So we're going to print me to the screen and see what we get. Now at this point in our constructor function, we haven't set anything else up. So I would expect to see an instance of employee with no instance properties. We can run the file and see what we get. Right here, I run person.js and I'm actually getting an error. We are getting a reference error. must call super constructor in derived class before accessing this or returning from derived constructor. So this is a very convoluted way of saying inside of our subclass constructor functions, we have to call the parents constructor function. That's going to make sure that things like first name, last name, age, and likes actually get set up correctly. We have access to the parents constructor function via super down below. So all we're going to do is call super. Super is this function up above. So we're going to call it with the arguments that this function expects. We have first name, last name, age, and likes. So we have first name, last name, with a capital N, of course, age, and likes. Now, with just that one call in place, we can rerun the script. And this time around, we can see what we probably expected. We're not getting an error. In this case, we are getting an instance of employee with those 4 properties set up correctly. Now that we have this in place, we can actually put the code in the constructor function that makes this employee class unique. And in this case, that's going to be setting up position. So this dot position equals whatever value happened to get passed in. Excellent. So there we have it, a perfectly valid constructor function. We override the existing one, still calling it to set up its attributes, then we define our own. Now, if we were to save person, we would actually be able to test this out. Down below, I am going to make sure to go ahead and provide a position. So right after the names and age, right here, I will just say something like teacher. Then after that, I will provide the likes. These arguments right here for employee need to match up with these arguments right here, and they do. I'm going to save the file and rerun things from the console. I'll use clear to clear up the output. Right here, I run the script, and what do I get? I get an employee with the 4 properties from before and position being set to teacher. So there we have it. Our constructor function has been overridden successfully, and we now have a unique piece of data on employee. We can take advantage of this piece of data by defining some methods down below. First up, I'd like to bring those 2 lines back into the mix. So I'm going to uncomment these 2 right here. And then I'm going to remove us just printing me to the console. That's no longer necessary. Now, currently, as mentioned before, when I call setName and getBio, it is going to look here for those. It's not going to find them, so it's going to look up above, and it's going to use these. Now, setName can probably stay the same. When I'm changing an employee's name, it's just the same as changing a person's name. But what if we wanted to change the behavior of getBio? In a more formal setting where I'm an employee and not just a person out in the world, I might not want to talk about my likes. Maybe I want to include something like my position at the company. So what we're going to do is override getBio for employees. We're going to provide a different method with a different set of behavior. Down below, let's go ahead and knock that out. Right here, all we're going to do is define getBio like we would have before. We're going to set up the arguments it needs. Now in this case, the version of getBio for an employee still doesn't need any arguments, so we'll leave those empty. Then down below, we're going to focus on the employee's version of getBio. Let's go ahead and say something like Andrew is a, followed by their position. So I might say Andrew is a teacher if that happened to be the position I provided. We can go ahead and knock that out with a quick template string. I'm going to return a template string. I'll start off with the name. Let's go ahead and actually use the first name and the last name for employees. So this dot first name, then a space, then right here, this dot last name, then is a, followed by their position and a period. I'll put that period in there first and the position right before this dot position. So what we're doing here is creating a brand new version of getBio specifically for employees. This is going to have no effect on regular people because we're not overriding anything specific to person. We're just saying, hey, if you're an employee, don't use that, use this instead. We can go ahead and save it and prove that everything I just said is true. I'm going to clear the terminal output. I'm going to go ahead and rerun things. And what do we get? I get Alexis Turner is a teacher, which is indeed correct. proving that setName still works and getBio is now using the different version. And down below, I still get Clancy is 57 because Clancy was created as a regular person. So he's still using the getBio method from person, which talks about the person's age, as opposed to the getBio method for employee, which leaves the age off. We can also add things onto the employee class that aren't just overriding things from person. We can add on something completely unique. Let's say that for this employee class, we're trying to figure out on average how many years an employee has left in terms of them working for our company. So let's say that if a person is 55, we expect most people to retire at 65, so they have 10 years left. We can create a little method specific to the employee that runs that calculation. Right here, we can call this something like getYearsLeft. I will set it up as a method. It's not going to need any arguments, and we're just going to perform a simple calculation where I return. We're going to start off with the average retirement age. Let's just say it's 65. I don't know if it actually is. And then we're going to subtract their current age. So this dot age. And there we go. We now have something unique to employee that at no point ever existed on person. Down below, we can actually call this. So console.log me.getYearsLeft. I'm going to call it, save the file, and rerun things from the terminal. I would expect that second thing printing to be the age right here. 38 sounds about right. 65 minus 27 being 38. So there we have it. By extending an existing class, we can override its behavior, and we can also add on brand new behavior, allowing us to customize things further without needing to duplicate a ton of code. We don't have to copy everything from the person class in order to create employee. We only have to define the things that actually make employee different. Now it's your turn to create a subclass of your own, and this subclass isn't going to be for the Hangman game because there really is no good subclass for the game. Instead, we're just going to make another one for person to give us a bit more experience creating these. So down below, what I'm going to do is delete all of the instances we have so far just to clean up the output and keep things simple. And I'm going to paste in the comments for what I'd like you to do. So the first thing you're going to be doing is creating a new class for a student. A student is going to extend from person. And there are a few things that are different about a student. First up, we are going to track the student's grade, represented as a number between 0 and 100. 0 being the least amount of points you can get, and 100 being the most, 100 being an A+. Number 3, we're going to override the bio to print a message about whether they are passing or failing the class. So if you have a 70 or above, we'll say something like Andrew is passing the class. If you have below a 70, you can say something like Andrew is failing the class, obviously inserting the correct first name there. Now the last thing we're going to do is create a new method as well called updateGrade. UpdateGrade is going to take the amount of points you want to add or remove. So if I pass 10 to upgrade grade, I'm not expecting the new grade to be 10. I'm expecting it to be 10 more than it was before. If I pass in -5 to upgrade grade, I'm expecting the grade to be 5 less than it was before. Then down below, you're actually going to go ahead and use things. So create student, print status. It should be failing or passing. Then you want to change the grade to get the opposite status. Change grade to change status. So if they were at a 90 and you were seeing the student was passing, go ahead and get rid of 40 points and then make sure you see the message that the student is failing. Print status again. Take some time to knock all of this out using what we learned in this video. Pause the video, test your work. When you're done, click play. Let's go ahead and kick things off by creating the student class right here, class student. The class student extends using the extends keyword person. Then we're going to go ahead and start defining what makes student unique. The first thing is that it has a different constructor function because we want to integrate grade. So right here, constructor. The constructor function is going to take things that a person needs, like first name, capital N of course, last name, age. We'll also add grade into the mix, and I'll put likes near the end. Then in the constructor function, we just have to do two things. We have to call the parent class's constructor function to make sure that those 4 attributes get set up. And then we'll set up grade, which is unique to student. So let's call super with first name, last name, age, and likes. Down below, the only thing we're going to set up that's custom is grade. This dot grade equals whatever grade was passed in. Now we can move on to steps 3 and 4. Let's go ahead and work on step 4 first. We want to create a new method called update grade, which allows us to add or remove points from the student's grade. Right here, we're going to add that in. Update grade. I'm going to take in the change, and then all we're going to do is access the grade. So this dot grade, we are going to add to it. So this dot grade equals this dot grade, the old value plus the change. If the change is positive, we'll be adding points. If the change is negative, we'll be subtracting points. Now we know we can simplify this using plus equals. So right here, plus equals is exactly the same thing. We're setting grade equal to its own value plus change. Now that we have upgrade grade completed, we can go ahead and actually create an instance of student before we even worry about overriding the bio method. Down below, const me equals a new student. And I'm just going to use my information in here, Andrew Mead, 27. Let's go ahead and give me an 88, and then I'll leave the likes array empty. And all I'm going to do for the moment is call the grade method update grade. So right here, me dot update grade. Let's say I did something to lose some points. I'm going to go ahead and pass in minus 20, bringing me from an 88 down to a 68. Then all I'm going to do down below is just console.log me. Console.log me. Whoops, it looks like I accidentally hijacked that closing parentheses from the line above. Let's make sure to keep that in place. Now we should be able to save person.js and actually test out what we have so far. I am going to call the file node person.js. Right here, I am getting a student with the grade of 68. So it looks like everything is going really well so far. Now, I also mentioned that I wanted you to use the getBio method twice, once before and once after, and override it. So let's add that call in first, me.getBio, after we make the change. And I'll also call me.getBio before I make the change. Before the grade change, I was passing. After the grade change, I am indeed failing. If we run the program as it currently stands, we're just going to see information about the person's age, name, and likes, the default one from up above. It's going to be calling getBio on person. We're going to go ahead and override that for a student right here. getBio. getBio takes no arguments, and all we're going to do is return a string. The only dynamic part of the string is whether or not they are passing. So we could use something like the ternary operator to figure out which one we should use, the word passing or the word failing, and then we can create our complete string. So right here, const status equals, we're going to look at this dot grade, checking if it is greater than or equal to 70. If it is greater than or equal to 70, after the question mark, we're going to use the string passing. If it is not greater than or equal to 70, we'll use the string failing. So there's another great way the conditional operator comes into the mix. Now that we've used the conditional operator here, also known as the ternary operator because there are 3 pieces to it, we can go ahead and move on to generating that template string. So I'm going to return a string starting with their name. So right here, this dot first name, then space is space, followed by their status. I just calculated the status, so I can include that right in. Then after the status, the class. So Andrew is passing the class, or Andrew is failing the class. Let's go ahead and run the program and make sure everything works as expected. Over here, I'm going to use clear, then the up arrow key twice to rerun the node command. Right here, Andrew is passing the class, shows up first, and Andrew is failing the class, shows up second. And there we have it. The challenge is all complete. In this video, we learned how to create subclasses of the classes that we defined. So we can take advantage of behavior from student, and also behavior from person, and also behavior from object.person. prototype. Now, I do want to mention that creating subclasses is not something we're going to find ourselves doing very often. It's not an everyday thing we do in JavaScript. We might do it every so often, but I did want to point out that it is possible with classes, and as we've seen, it's actually pretty easy to get done. That's where we're going to stop for this video. I'll see you next time.